And welcome to this video, which is an IGCSE explainer all about moments. And this is from the physics course, of course. We're going to talk about what moments are, the kinds of situations where we might apply a moment, and then how we calculate moments. And finally, look at some slightly trickier conceptual points, which I know that students have a lot of trouble with when they are trying to identify the numbers that they try to use. So let's get to a really good example of moments is the picture you can see on the screen. This is a spanner or wrench, and it's trying to cause some rotation. Now, if we're using a wrench, we're trying to loosen something or tighten something, we would rotate it in different ways, and we do that by using our hand to apply a force. Now, usually you would apply your force at one end of the wrench, and that's because, hopefully you know from your everyday experience, that's what makes it easy for us. Now, without knowing it, you're actually applying something called the application of moments here, and that's what we're going to discuss today. So put very simply, when we're talking about moments, we are referring to the turning effect of a force. So every time we deal with moments, you'll notice this in questions about moments, they're always about situations where something might turn. So in this case, we've got the wrench, which is going to turn about a point, and that point is we're going to call a pivot. Now, some basic points about moments is that they can have different directions. You'll notice in this case, the action of that force F is going to cause the wrench to rotate. And it's going to rotate in a particular direction. It's going to rotate in the clockwise direction. Well, it's also possible for us to have anti-clockwise moments as well. So we might talk about positive or negative moments. We might talk about clockwise or anti-clockwise moments, especially when we're talking about balancing things and making sure that we have things in equilibrium. Now, when we want to calculate a moment, it's quite simple. We take the product of two numbers. And in this case, we take the product of the force itself and then that distance. And what we're going to do is we're going to call that distance the perpendicular distance from the pivot. Now, in this case, you can see it very clearly on the screen. That's just D. Don't worry about this term perpendicular. I'll discuss that a little bit more detail at the end of the video. Just be happy right now. We're thinking about the length, in this case, of the wrench. So our moment M is simply a product of force times distance. And what you can see there is that if I have a bigger force, I'm going to have a bigger moment, and a bigger distance, we're also going to have a bigger moment. So really what we're saying there is if we want some rotation to happen, we can cause more rotation to happen by having, say, a longer wrench and also applying a greater force. So take your time to familiarize yourself with that equation, and then when you're ready to go, have a try of this question. We've got a force of 6 newtons applied to this wrench, and our wrench has got a length of 0.15 meters. Let's calculate the moment. Feel free to press pause and try it yourself, and then press play again to see what the answer is. Hopefully you've had a chance to try that one. Okay, we're going to use our equation here, m equal to fd. Okay, we know our force is 6 and our distance, in this case, is the length of the wrench, where we're going to apply the force, 0.15, and then we get this answer, 0.9. Now, you might have not been too sure about the units here. The units of force are newtons, units of distance are meters, and so in this case, we just say that the moment has a unit of newton meters. So it says that we're going to have a turning effect, which has a magnitude 0.9, and we have units newton meters there. Okay, let's try a slightly different problem, and again, feel free to pause and try this one. What if we said we've got the same wrench, but this time we're going to apply a moment of 15 newton meters. So we're really going to say here, what is the force we are required in order to apply that moment? And we'll remember here, our length is 0.15 meters. Feel free to pause and then have a go at the question, and then press play to see the answer. Okay, hopefully you've had a chance to try that. Now you could do this a couple of different ways. I'm just going to put the numbers in. We know the moment is 15, and we know the distance is 0.15, but we don't know that F. Obviously what we then need to do is divide both sides by our 0.15, and we end up with a force which is going to be equal to 100 newtons. Okay, So that's just an example of two types of questions which you might be asked to calculate. And really it's just a case of being able to put the numbers in, remembering that definition that the moment is the product of the force times the distance. Now, you could stop there, that would be enough. However, there is one small thing that we need to kind of just address, as I've noticed this comes up in a few of the questions, and it's a bit tricky, it's quite a conceptually very hard point. We mentioned at the beginning of this thing that we call the distance there the perpendicular distance. Now, perpendicular means at right angles. And so you can see on the left-hand diagram that we've got a distance which is horizontal and a force which is vertical. And what that means then is they are at right angles. Now, the tricky bit comes when they're not at right angles. However, I've noticed that this kind of is a wavy point in terms of GCSE. Sometimes it comes on, sometimes it doesn't. So I'm just putting this out there just to show you what we do in the case where we don't have right angles. Usually we have right angles. So usually you'll be dealing with a point similar to situation on the left-hand side. However, every now and again, you will deal with a situation like this. Now you notice here in this case, we've got a bar which is horizontal, but a force which is non-horizontal. Now the bar and the force are no longer at right angles. So we have to use a different distance. You notice here, what we do is we draw a line which cuts that force vector at right angles. We draw it from the pivot through to the end of that force vector, and that would be the size of the distance that we use in this case. That would be the perpendicular distance because it's cutting at right angles. Now, as I've said, this really doesn't come up that often in terms of the calculation questions. However, I've noticed, and those students in my class will notice as well, there are a couple of multiple choice questions where this comes up. Okay, so remember that when we're looking for that distance that we want to use, we need to use the perpendicular distance, which usually is cutting our force at right angles. Okay, don't worry too much about this. Hopefully we'll see some examples as we work through, and please feel free to ask any questions if you have them as they come up. Thank you for watching.